sound is a mechanical longitudinal wave, meaning it's going to require a medium to propagate. It consists of alternating compressions and rarefactions, as you can see in the pictures, as the molecules in the medium are going to oscillate back and forth. So, sound needs a medium to travel because it relies on these particle interactions to transfer energy. So you can compare this to a domino effect, for example, and you can see it in the pictures. So what is sound power? Now, sound power is the rate at which energy is transferred by a sound wave. Therefore, this property, as you can see, is particular to the source itself. It does not change. It does not depend on distance. It stays constant, obviously, if the source is emitting a constant sound in volume. Now, the power is measured in watts or joules per second, just like the power of a light bulb. And the formula for power is going to be the energy emitted by the sound in joules and the time in seconds. Now, we cannot mix this up with sound pressure. Well, sound pressure is another way to measure sound level, and it uses pressure, which is the actual input that we get in our ears, making our eardrums vibrate and we perceive sound that way. However, sound pressure depends on distance. Another formula to figure out the power would be using the sound intensity formula, which we're going to see later on, and rearranging it to get power is equal the sound intensity times the area at which the sound is propagated. Next, let's look at sound intensity. Now, sound intensity is going to be the power per unit area at a specific distance, and it's measured in watts per meter squared or joules per second times meter squared. It is dependent on distance, and it decreases as distance increases in an inverse square law manner. So obviously, volume and sound are still kept constant, and the intensity of sound is also dependent on the medium. So the formula for the intensity of sound is actually the power divided by 4 pi r squared, where r is the radius of the sphere in meters, or the distance of the person that is hearing compared to the source. So with this formula for sound intensity, we get that sound intensity is going to be inversely proportional to 1 over r squared. So if you move two times away from the initial place you were from a speaker, you're going to find that the intensity is going to be a quarter of the initial intensity. So let's talk about power, sound intensity, and sound pressure interlinked. So since power is going to be the energy per unit time, we have to consider the kinetic energy of the medium's particles in the sound wave. So if the sound pressure increases, let's think about this. This is going to mean that there's going to be more fluctuations in the air pressure due to the air particles that are going to be oscillating. This means that they gain more kinetic energy, so they oscillate more, meaning that the sound power has increased and that the sound intensity has also increased, since it depends on the sound power, as we saw previously. And another way to see how sound pressure and sound intensity are going to be interlinked is that the sound intensity is actually going to be proportionate to the square of sound pressure over the density of the medium times the speed of sound in the medium. Now, what are decibels? The decibels are going to be a logarithmic unit scale used to measure sound levels. Our ears don't perceive sound intensity linearly, they respond logarithmically. And this is why we're going to use sound levels in decibels instead of watts per meter squared, for example. And it's more intuitive because an increase of 10 decibels is 10 times more intense. Our ears respond to huge intensity differences, in other words. As you can see, there are many conversions into decibels for different sound levels. So now what did we learn? What is sound power? It's the energy emitted by sound per second. What is the sound pressure? It's what we perceive as sound. It's the variations in the air pressure which cause our eardrums to vibrate. Now, sound intensity is going to be describing how the power is distributed over an area, and it's going to influence this sound pressure. And last but not least, the decibels are going to be the logarithmic scale that is used to measure sound levels for humans, and it's most commonly used for the conversion of sound intensity. Did you listen? Now, if you move 8 times as far away from a source, what happens to the sound power? Why? And what happens to the sound intensity then? Why? Thank you.